I'm Pat Dugas. This first part in a two-part series on polynomial operations will deal with the properties of exponents, specifically as they relate to multiplying, dividing, and simplifying monomials. The second part will deal with addition, subtraction, and multiplication of polynomials. So let's take a look at some of the properties of exponents here, because they're crucial in being able to simplify and solve both monomials and polynomials. So if we're looking at two numbers that have powers in them and we want to multiply them, we add the powers. So x to some power times x to some other power is equal to the sum of the x to the sum of the powers. For example, if we have 3 squared times 3 to the 4th, we get 3 to the 2 plus 4, or 3 to the 6. If we are dividing terms that have powers, such as x to the a divided by x to the b, that's the same thing as x to the a minus b power. Provided that x is not equal to 0, then we'd be dividing by 0. For example, if I have a quantity b to the 6th divided by b to the 4th, that is b to the 6 minus 4, or b squared. Now, what's true for all of these things is these operations only apply if the base is the same. In other words, that x, you have to be multiplying an x by an x, or dividing an x by an x, or any of these other operations. The base has to be the same. Otherwise, these properties don't apply. Negative exponent property. So if I have some number x raised to the negative a power, that is the same as 1 divided by x to the a. Similarly, 1 divided by x to the minus a is equal to x to the a. Again, provided that x is not equal to 0, because we don't want to divide by 0. This is actually a special version of the quotient property, because it's kind of like x to the 1 is like x to the 0. Okay, and so x to the 0 divided by x to the a would be x to the 0 minus a, or x to the negative a. For example, if I have 3 to the negative 5 power, that can be rewritten as 1 over 3 to the 5th. If I'm raising a base to a power and then raising all of that to another power, in other words, x to the a all raised to the b power, that is the same thing as x to the a times b power. If we're raising a power to a power, we are multiplying the powers. That's often confused with product of powers. If we are multiplying two powers, x to the a times x to the b, we're adding the powers. But here we're raising a power to another power. So for example, if I have d squared, d to the second power, and I'm raising all that to the 4th power, that is the same as d to the 2 times 4, or d to the 8. If I have a product of things, and I'm raising that product to a power, then, for example, xy, this quantity is being raised to the a power, that is the same as x to the a times y to the a. It's very much a distributive idea. This can only be done if they're multiplied or divided by each other. So for example, if I have something like 2k raised to the 4th power, that's going to be the same as 2 to the 4th power times k to the 4th power, or, since 2 to the 4th is 16, 16 times k to the 4th power. We are essentially distributing each of those terms to that power. A similar thing is done with the power of a quotient. If I have a quantity x divided by y, and that's all raised to the a power, that is the same thing as x to the a divided by y to the a. Again, in a similar way, x over y, x divided by y to the negative a power, is actually the same thing as y divided by x to the a power. That takes this negative exponent property and applies it as well. So it's basically the same thing as y over x to the positive a power. An example of this, if I have x over y all raised to the 2nd power, that's the same as x to the 2nd power divided by y to the 2nd power. And finally, a very important property, even though it seems minor, is any value raised to the 0 is equal to 1. So let's look at some basic ideas for what it means to simplify something. You see that verb a lot, simplify this, in mathematics. And what that's trying to do is take an expression and turn it into something we can more easily work with. So a monomial, which is a single term expression, is simplified once there are no powers of powers. We've taken all the powers of powers out, like x to the a to the b. Also, each base should only appear once. We should have resolved all the other versions of that base. So there should only be one x or any other variable that you see there in the expression originally. All fractions should be in simplest form. So if we take 6 over 8, we need to turn that into 3 over 4 to be in simplest form. They're equivalent fractions, but 3 over 4 is in simpler form. And finally, there are no negative exponents. Ideally, we get rid of those negative exponents, use the negative exponent property to actually turn them into positive exponents, either in the numerator or the denominator is appropriate. So let's look at simplifying a monomial expression. So we have a to the negative third times a squared b to the fourth times c to the minus 1. We're going to assume that no variable equals 0 because that could cause us to divide by 0. So we're one by one going to get this down to simplest form where each variable appears once, there are no negative exponents, etc. So we take our original expression and we see a couple of negative exponents. So we're going to use our definition of negative exponent property, take a to the minus 3 and turn that into 1 over a to the third. Take c to the minus 1 and turn it into 1 over c to the 1, or just 1 over c. Now, once you learn this process, you don't necessarily have to list out each variable as many times as they are raised to a power. But we're going to do this just for visualization. So 1 over a to the third is the same as 1 over a times a times a. Equivalent expression. A to the second times b to the fourth is the same as a times b times b times b times b. Okay, so I've got 2 a's and 4 b's multiplied by each other, and 1 over c. What we're going to do now is divide out things that they have in common. Well, there's 2 a's in the numerator that can cancel out 2 a's in the denominator, because a to the first divided by a to the first is equal to 1. In this case, a to the second divided by a to the second is equal to 1 as well. There are no b's anywhere else, so we're going to leave those 4 b's alone. And that's pretty much all we can do. So the 2 a's cancel out in the numerator and the denominator. We're left with 4 b's in the numerator, 1 a in the denominator, and 1 c in the denominator. Now we can only, to keep it in simplest form, we have to simplify b times b times b times b and turn it into a single b term. And so that is the same as b to the fourth. So we have b to the fourth divided by the quantity a times c, and that is our simplified monomial expression. All of this, which is algebraically equivalent to this at the bottom, is rewritten so that it's a simpler expression to deal with. Let's look at another example, again assuming that no variable equals 0. We're taking the expression 3a to the third divided by b to the fourth, all raised to the second power. So again, we're going to write that expression and then deal with each part one at a time. So using the power of a quotient, this entire portion in parentheses is raised to the second power. So that's the same as the numerator, 3a to the third, being raised to the second power, and the denominator, b to the fourth, being raised to the second power. So now we're going to break out each part of it. So 3a to the third, all raised to the second power, is the same as 3 to the second power times a to the third to the second power. I've broken out each of those parts and raised them to the second power as a result of the power of a product. Finally, in the denominator, b to the fourth raised to the second power, we're just going to kind of leave it alone. So if we take 3 to the second power, that's 9. And a to the third raised to the second power, using the power of a power, that's a to the 3 times 2, or a to the 6. B to the fourth raised to the second power, that is b to the 4 times 2, or b to the 8. And that's all we can do. That's our simplest form. This monomial originally has now been simplified. In this screencast, we focused on the first part of this, which is using the properties of exponents to multiply and divide monomials, simplifying them.